In this example, we're going to look at the rate model for representing fractions. So notice we have a lot of different models, and maybe you haven't thought about these before, but think about all the different ways to represent fractions. So it's important that you realize that there's so many different ones because it can really open your understanding to fractions in general. So remember we said in the last video that a rate compared multiplicatively two different types of units. And when we're saying units, we mean the things that we're measuring. So maybe in this case, I think we're going to be looking at miles and hours. Okay, so in the part-to-part ratio, we were looking at different types of things. We had, say, chocolate candies and peanut butter candies, but they were both candies. They were different types of candies. Here we're going to be looking at two different units. Miles and hours, and that's when we call it a rate. And you're probably familiar with some rates. When we look and compare miles to hours, we're talking about speed, your rate of speed. That's a type of rate. Or you may know of, I think we discussed hourly rate in the previous video. So that would be how much you make, say, per hour. So if your boss said you make $800, well, that's nice. $800 a week is a lot different than $800 per hour. So rates are giving us the relationship between two quantities, and we really need to know what the units are in each. So let's look at the first example. We're going to represent these as fractions. A snail travels 3 miles in 6 hours. Okay, and looks like we're asked two questions here. What fraction of miles to hours does he travel? We're also asked what fraction of hours to miles does he travel? Okay, and those are so slightly different. I feel like I said the same thing twice, but notice I actually didn't. In the first one, we're looking at miles to hours, and here we're looking at hours to miles. So when we have rates, again, with fractions, the order matters, which one is the numerator and the denominator. And here we're asked miles to hours, which means miles will be the numerator and hours will be the denominator. And here hours will be the numerator and miles will be the denominator. So you look at the word to, and the unit preceding it is the top and the unit after it is the bottom. Okay. So I'm going to start this first one. It's nice to write your units as a fraction, miles, hours, like we've been doing, and that will help you set up the problem correctly. So here, the snail, it's 3 miles in 6 hours. Okay, and I'm going to write my final unit as miles per hour. Okay, so this is our fraction. Okay, and again, notice we've made a different type of unit here. We started with miles. Miles measures distance. Hours measures time. Okay, distance and time are two different things, but they're related here. And miles per hour isn't talking specifically about distance or time. It's talking about distance over time, which is speed. So this is a rate of speed. So notice rates can really transform what we're talking about. We're comparing the miles in the amount of time, and this tells you how fast the snail is going. So we have 3/6 miles per hour. Okay, and we're not going to simplify fractions yet. Again, you may remember this from another class. We'll do this in the next lesson. But you may know that 3/6 is the same as 1/2. If you don't, that's okay. We'll discuss it later. But so this snail is going 1/2 of a mile in 1 hour. Okay. Now let's look at the fraction of hours to miles. If we write the hours to miles, that would be 6 hours in 3 miles. So we'd say 6/3 hours per mile. Okay. So in a way, this tells us about a rate of speed, but it's different from this one. Okay. So here we said we could think of this as the snail is going 1/2 of a mile in an hour. Notice if we simplify this, we would get 2. 6 divided by 3 is 2. So it takes the snail 2 hours to go 1 mile. Okay. So they're giving us the same information, but in a different order, and the order really matters, and the units matter. They tell us a different situation. So how fast is he going? He goes 1/2 of a mile in an hour. Here we can say it takes him 2 hours to go 1 mile. Okay, it's the same information, but in a different context and a different way to interpret it. So now let's look at the next one, which is very similar, except a rabbit, so he's going faster. A rabbit travels 6 miles in 3 hours. What fraction of miles to hours does he travel? And what fraction of hours to miles does he travel? Okay. So notice it's the same 2 questions as we saw here, but the miles and the hours are different. Okay. So miles to hours for the rabbit is going to be 6 miles in 3 hours. 6 miles, 3 hours. So this is the miles per hour. And now we can say that if you divide 6 by 3, we know this is 2. The rabbit is going 2 miles per hour. Remember, the snail was going 1/2 of a mile in an hour. So the rabbit is actually going 4 times faster than the snail. I'll let you think about that, okay? Because in 1 hour, he'd go 2 miles, he'd only go 1/2 a mile. So that would be 4 half miles and 2 miles. Okay, so again, changing the order of these numbers really makes a difference. And if we want to think of it hours per mile, it would take the snail 3 hours to go 6 miles. So there's the 3 hours, 6 miles. So 3/6 hours per mile. Okay, so if we simplify this, it would take the rabbit 1/2 of an hour to go a mile, whereas it took the snail 2 hours to go a single mile. Okay, so I hope you're seeing how this rate model is different, how we're comparing these quantities, and how the units matter and the order matters. We have one more type of model for fractions. It's going to be the exchange, conversion, or operator model we're going to look at next.